We are going to continue our practice with one-sided limits. We're going to look at this graph right here. I've picked out three different x values. I've picked out x equals -1, x equals 0, and x equals 3. And for each of these x values, I'm going to ask the same four questions. We're going to look at what is the left-hand limit, what is the right-hand limit, what is the two-sided limit, and what is the value of the function at that x value. So we've got these three different x values, but we're just asking the same four questions for each of these three different x values. So let's go ahead and start with -1. We're starting with x equals -1, so identify that point on your x-axis. Let's start with the left-hand limit. Sometimes I actually think it's quite tricky when you're very first starting off to identify kind of which side of the graph do I start on and which way do I trace backwards. The left-hand limit says you're going to start on the left-hand side. So I've identified -1. Let's move over to the left-hand side of -1. We'll find our function at that point and then trace our function backwards to x equals -1. So, okay, we want to ask ourselves, what y value are we getting closer and closer to right here? Or what y value is our arrow pointing at here in this case? Here, we're getting closer and closer to a y value of +3. So that means our left-hand limit is +3. We're going to repeat this same process, but now we're going to be looking at the right-hand side. Just erase that point. So again, we're still looking at -1, but when we look at a right-hand limit, I'm going to move just a little bit over to the right. I'm going to find my function at that x value, and then I'll trace my way backwards to x equals -1. I want to be getting closer and closer to x equals -1. In this case, we're pointing at this open circle right here. We're getting closer and closer to that open circle, which has a y value of +2. So that means that the right-hand limit must be +2. So at this point, we should have enough information to answer part C. We said that the left-hand limit was 3, the right-hand limit was 2. Because these two things are different, because the left-hand limit has a different value than the right-hand limit, the two-sided limit then does not exist. I don't even necessarily have to look at the graph of this function. I could if I thought that would help me, and you could if that is helpful for you. But on a quiz or a test, I might say, hey, here's a function. Here's its left-hand limit is 3. Its right-hand limit is 2, and then I might say, okay, well, what's the two-sided limit? What's the value of the two-sided limit? And in that case, we could say, well, because they are different, that limit does not exist. Lastly, we want to talk about what is f of -1. What's the y value of our function at -1? So we're going to keep looking at x equals -1. Here in this case, we want to look for any closed circles that we might have. Remember that an open circle means that the function does not exist there. That's a hole in our graph. But in this case, we've got a closed circle right there. We just want to identify what the y value of our graph is. Here we have a y value of 3. So f of -1 is equal to +3. And there we go. That's pretty much everything we can say about the behavior of our function at and around -1. So let's change gears. Now let's take a look at x equals 0. Let's see what happens there. So at x equals 0, again, we want to start with the left and the right-hand limit. So here's x equals 0. Let's start with the left-hand limit. So we'll move a little bit over to the left. Find our function, and then trace our way back towards x equals 0. Here in this case, we're getting closer and closer to that open circle, which has a y value of positive 1. If I wanted to look at the right-hand limit, I'm going to move just a little bit over to the right, find the value of my function, and then trace my function and ask myself, what y value are we getting closer and closer to as we move closer to x equals 0? In this case, we're once again looking at that open circle, which has a y value of 1. So the left-hand limit is 1. The right-hand limit is 1. So we have enough information then to jump down to part G. It says, what is the value of the two-sided limit of f of x? And in this case, the left-hand limit is 1. The right-hand limit is also 1. That tells us that the two-sided limit should also be 1. And that's another type of question I could ask. I don't even necessarily need to look at the graph. Again, you can if you think it's helpful, but I might say, okay, I don't know what the function looks like, but I know that its left-hand limit is 1. Its right-hand limit is 1. So that means its two-sided limit then must also be 1. So if the left and the right hand are equal, the two-sided limit must also have that same value. The value of the function, though, is not necessarily related. So if I look at the value of the function, so far all of the points that we've looked at have revolved around this open circle right here. But we just said an open circle represents a hole, so our function does not exist there. So we want to look for any closed circles that we might have, and here we do have one right here, down here. Looks like we have a y value of -1. So f of 0 is equal to -1. So again, just to emphasize, the value of the limit will not always be the same as the value of the function. Those two can be very different things. Let's take a look at x equals 3 for our last x value. So x equals 3, we're talking about this x value right here. We happen to have a hole already at x equals 3. So if I start with the left-hand limit, we'll move a little bit over to the left, find the value of our function, and then trace our way backwards towards x equals 3. Here in this case, it looks like we're getting closer and closer to a y value of -2. So we're getting closer and closer to -2. Again, even though we have an open circle, it doesn't really matter. So okay, we have the left-hand limit. Let's look at the right-hand limit next. So this time I'm going to move a little bit over to the right and then trace my way backwards to x equals 3. And it looks like we're getting closer and closer to this open circle right here. That open circle has a y value of 0, right? It's right on the x-axis, so the y value must be 0. So again, at this point, I have the left-hand limit. We said that was -2. The right-hand limit, that's 0. The two-sided limit then, because those two were not the same, that does not exist or is undefined. Lastly, the value of the function f of 3. So f of 3, what's the y value of our function? Remember, we're looking for any closed circles that we might have. Here in this case, we've got one right here, and that has a y value of 2. So that means that f of 3 is equal to 2. So be very careful as you're working through these problems. You may have instances in which the limit is equal to the value of the function. You may have examples where all 4 of these things are the same. But you may have some instances like over here at 3, the left-hand limit was -2, the right-hand limit was 0, the two-sided limit did not exist, and the value of the function was 2. Each one of those was a completely different value. So just be careful as you're working through these problems. You will get better at them with practice. So I would highly recommend practicing looking at some graphs and evaluating one-sided limits. That's the best way that we're going to improve evaluating these types of limits.